Next on our agenda for the day is Lewis Baarda, who is the On-Farm Research Authority at Farming Smarter. Farming Smarter is wrapping up a field research trial testing site-specific approach to controlled kochia patches. The research project explored using mapping techniques to identify kochia patches and deal with these patches using targeted efforts rather than a blanket approach. Lewis will discuss the strategies tested, what worked and what didn't, and how we may be able to use these techniques to better manage kochia weeds. Please help me welcome Lewis.
Okay. Hi, everybody. Today I'm going to talk, as we mentioned, a little bit about a project we've been working on the last 4 years now, focused on kochia. So if you're farming on the Canadian prairies, we're all kind of connected to this. You've heard about kochia. It's kind of a big concern right now. And before I get into the weeds, so to speak, on this, I'd invite you to take a look at your Slido app in your phones. So I've sent out a poll. Sean helped me put together a poll, just kind of talking about resistance. So I'm just curious to see what your perspective is on resistance that you're seeing in kochia on your own farms. And then in a few minutes, we'll kind of see how that matches up with some of the data that we've, some of the research and surveys. So kochia, a moving target. So kochia is, again, it's been a big issue. I'll kind of get into some of the details on it. But we wanted to look into whether we could manage this with a variable rate or site-specific strategy. There's a lot of different pieces that come together to effectively manage kochia. So we thought if we can narrow down the scope, if we can manage it in 20-acre, 30-acre, 10-acre pieces, maybe it'll be a little bit easier to deploy some more of the tools in our tool belt to tackle kochia. So with that, I'll kind of go through the presentation starting with a little bit about kochia. So what do we know about kochia? Why is it such a big concern? Then into the weed mapping, some of the things we did to try to map kochia, figure out where it is in the field, and then some of the specific site-specific controls that we implemented in these patches. So kochia, to begin with, it's a major, it's well evolved for life on the prairies. It's a huge seed producer. It produces 20, 30, up to 50,000 seeds per plant. So that's a lot of seeds that can propagate and sprout up the next generation. It has a prolonged emergence. So not only can it emerge earlier than a lot of different weeds and a lot of crops, but it'll kind of emerge throughout the season in flushes. So it's not just a 10-day certain growing degree window where you can hit it and you've dealt with it. It'll kind of continue to flush over, perhaps a 3-month period. So it's not one that you can just hit it and you're good to go. So that makes it really challenging to deploy those control measures. It grows fast. It's tolerant to heat. It's tolerant to drought. It's tolerant to salinity. So so for that reason, when we get drought conditions, when we've got marginal lands, kochia really thrives. And in fact, it's not a very competitive weed. If there is good competitive crops around it, they'll tend to choke out the kochia. So that's one of the good tools that we have, is just to outcompete the kochia. It of course transports really well. The tumbleweeds that kind of roll through the fields. I'm sure you've all seen pictures or seen in the fields, sort of that strip of kochia where one tumbleweed plant rolled through the field, and suddenly we've got a problem to deal with again the following year. And the last couple of points here kind of speak to the aptitude for building resistance in kochia populations. Each plant is quite genetically diverse, and they cross-pollinate, meaning that this plant can pollinate a plant over here. So there's a lot of opportunities to build new genetic traits, genetic characteristics, and perhaps some of those being resistant. The last piece there is a quick generational turnover. So kochia, the seeds are viable for 1 or 2 years in the soil. So on the one hand, if we can control it for a couple of years, we're in pretty good shape. But if we don't, it gives any new genetic characteristics that develop, we have to deal with them right again the next year. So it's not like a 10-year process. So some of these changes on a population basis can happen quite rapidly. So on resistance, so this is where might be interesting. I don't have the Slido with me, but to look at the results of that poll and just kind of see how well your perception of what's happening out here in southern Alberta lines up with some of the surveys. So this slide is actually from 4 or 5 years ago. When we started the project, I shared this. It was the most recent weed survey at the time. So group 2s at that time, 100% resistant. Group 4 dicamba was 18%. Glyphosate was 50, which was a huge jump from the survey before. In 2012, it was only about 5% resistant, so that's a huge change over a short period of time. And 10% of fields surveyed had stacked resistance to groups 2, 4, and 9. So that was the first time we had seen that, and that's a big issue. So we fast forward to today. The most recent survey was about a year ago, and they didn't even look at ALS inhibitors. They're assumed to be resistant across the prairies. Dicamba went from 18 to 28%. And there's also another chemistry within the group 4s, the fluroxapyr, which is about 44% resistant now. So there's 2 different chemistries within that group 4 that have resistance, so something to pay attention to. Glyphosate is at 78%, so 4 and 5 fields are going to be resistant to glyphosate. So at this point, we should pretty much be assuming that kochia is resistant to glyphosate. And then 45% are at that triple resistance. But I'll note that triple resistance means one of the 2 chemistries in the group 4. So if you are using group 4s and you rotate between chemistries, it's better than sticking to one, but certainly caution advised. So just a bit of a timeline on that. So 1988, we started to see resistance. I think it was 2007. Glyphosate resistance was found in Kansas. 5 years later, we found it here on the prairies. 2015, dicamba. 2017, 50% of glyphosate. And again, today, we've got stacked resistance, and the vast majority of sites surveyed have resistance to glyphosate. So for a lot of these reasons, the properties of kochia and this resistance mechanism, it does tend to manifest itself in patches in the field, again, where there's marginal lands, where there's salinity. So I've just got a few examples that I've sort of seen in the last number of years of risks for kochia being established. And again, if we have a little bit of kochia in a field, it can really change in a hurry because this weed spreads fast. So this was one field that we had worked in on this project the last number of years, and we've got a power pole and a well site here. And that's it's a huge risk for kochia. It's very difficult to farm around it, and there's probably nothing wrong with the soil there, just a matter of the difficulty of farming around it. And with a weed like this, it's something to consider. What are the cost benefits of getting out there and finding an alternative means to control that, hand spray or getting a quad out there kind of thing. Marginal areas, field edges, saline areas. Crop competition. So this was from our Farming Smarter site this year. We had some issue with antagonism when we were spraying our filler crop, our durum wheat crop. And coming back a week or 2 later, what had been sprayed, knocked that wheat back big time. So it was really struggling. And we came back and the kochia was just doing really well. So just reducing that crop competition gave kochia a huge opportunity to grow. So whether that's, in this case, a sprayer issue, but any time you have marginal land, less competitive crops, kochia is going to find a way to get through. So just a really good illustration of you think about a hot, dry environment some years in southern Alberta. Kochia loves that. Seed canola. Seed canola is another big risk. We've got the male bays, there's conventional herbicide options, and they're mowed out, and there's no crop competition. So that kochia, again, can really, really take off. And I think for some of our high-risk crops, seed canola certainly isn't the only one, but it's probably worth thinking about how we're thinking about rotations, how are we going to knock back kochia ahead and after some of these higher-risk crops. So the next step for us was sort of the weed mapping. So this is, a bit of a summary on kochia and why it grows in patches, why it's an issue. But we wanted to take the next step and sort of figure out, can we identify where it is and use that information to manage kochia? This slide, I kind of like it because it gives a really good example, one of sort of that, patch establishment in kochia. So in the foreground, we're standing in the dry corner of a wheat field. So in the foreground, it's quite sparse wheat there. little competition. This was in 2021 when it was really, really hot and dry. And in the background, the wheat's actually doing really well. So the Kochia's outcompeting, the wheat in the foreground without much challenge. And the other thing to note is just the difference in color. So this is sort of an opportunity for us in the mapping standpoint where the Kochia is still green when the crop has senesced. So that difference between the vibrant green Kochia and the brown crop was an opportunity for us to perhaps fly drones over fields and identify where Kochia is. So that's what we did. We mapped a bunch of fields, or 3 fields over a 4-year period, each of them. We collected a variety of other information from them as well, soil samples, conductivity, weed counts. We did yield maps as well. And I do want to just touch on some of the imagery side of things. So we took an approach where there is multispectral technology available. So that's something that can measure, basically what a drone does is measures reflectance in different parts of the spectrum. And a multispectral can measure like a lot of things. Ostensibly in a lab, it can differentiate between different green plants. But I spoke to somebody, about a couple of months ago and kind of asked them about this, and they said, yeah, I can tell you the difference between plant A, B, and C, but when you get to the field, it's a little bit different. You've got things like shadow, you've got the angle of the leaves change, and some of these things can change reflectance by up to 30%. So although it is ostensibly possible to differentiate all sorts of things in a controlled environment, when we get out to the field scale, it does become pretty challenging. So that's where the opportunity for us was sort of that green on brown detection late in the season collecting imagery. So most drones will have the capacity to collect light in the RGB, so red, green, and blue parts of the spectrum, and we kind of put that together to make a true color image. Some drones will have that infrared capacity. So, to kind of put it simply, infrared red will give us that NDVI index, which tells us a little bit about when and where that plant's growing robustly. Again, we're looking at green on brown, so it's a really striking difference. There's also another technique that can just use, some band arithmetic between the red, green, and blue to develop what's called excess greenness. So, long story short, there's 2 different ways to sort of show us, where the greenness is in the field. We don't have to supervise it. We don't have to zoom in and tell the model what's happening. It's pretty autonomous. They're pretty standard ways to go, and they actually did a really good job for us. Just a quick note on thresholding. Again, we've got green and brown. So we've got a pile of observations over here that are green, a pile that are brown. It's really easy to separate them, so we know what's green, what's brown, we know what's weed, what's not. If you were collecting imagery sort of in season, that range is not going to look, that distribution won't look so bimodal. It's going to be really hard and a little bit more subjective to sort of say what's a weed, what's not. So this is what it looks like at the end. So we've mapped our field, we've run it through a couple processes, and we've got a map that shows us what's a weed and what isn't. So I'll just take you through one of the fields that we studied. 2019 was spring wheat, 2020 was faba beans, 2021 was flax, and 22 was canola, Roundup canola. So you notice that the spring wheat in the top left and the canola on the bottom right, there is a difference between the color differentiation depending on the crop, depending on the timing of the imagery taken. So there's probably some subjective decision making in when to fly a drone. The faba beans on the bottom left, it was actually kind of challenging to differentiate the weed from the faba beans just because of the color, because of the late senescence of the faba beans. The Kochia is a bit of a darker color as well. But we also did have pretty control there because we had some good herbicide options. So you can see that converts into weed maps. This next slide, each of those green circles, the sides of the circles kind of represents how many weeds we saw in that location. So I'd say, across the board, we were probably 80 to 90% accurate in identifying weeds using that imagery. So that was kind of a good first step to be able to say, okay, we can identify where the weeds are. We know we're actually relatively accurate with it. And here's another, I guess, example of the same thing, just showing how accurate we were. So the colors of the circles sort of correlate to how many weeds we found in those locations. So we know we can map Kochia. We know we can do a pretty good job of identifying where it is, and it's relatively accurate. So the next step was to look at what can we do to use this information. So I'm just going to share a couple of examples of things we did in a few of our fields that I think, yeah, just kind of shows the opportunity with knowing where kochia is and allowing us to deploy, sort of a herbicide layering, technique layering approach to kind of tackling kochia where it is without having to handle the whole field. So here's our first year. Here was our weeds on a spring wheat crop. So we applied a variable rate herbicide. So in this case, we applied Authority over a third of the field ahead of faba beans, which gave us really good control. So there is some green on brown technology out there, sort of the Weed It system, See and Spray, that'll kind of real-time examine. They'll be able to identify a weed and spray it in real time. The advantage of an approach like this is when you're using a soil active herbicide, soil residual, Authority type product, is you may be spraying it before those weeds are actually visible, so we can be confident we're spraying it where we know there's going to be weed pressure and getting that efficacy without having to see them actually growing at the time. And here's kind of the outcome. We really knocked back the weed population by using that Authority. We didn't have a whole lot of weeds established outside of where we applied the Authority. So in this case, we applied 25 to 30% of the field with Authority and had the same control or very close to the same control as if we had applied the full field with Authority. So that to me is a pretty good option for integrating another herbicide group, another approach without having to apply it across the full 160 acres, 135 irrigated acres. Another idea is sort of a zone-specific chem fallow. So here's another wheat field. So I overlaid the EC map on top of it because it kind of shows where it's greener. It did kind of give us some insight to where kochia would be established, where there's a little more salinity. Turn that into a pretty effective map of where kochia is. And again, in this case, we're going into a durum wheat field, and we were able to apply Authority. So Authority registered for spring wheat, durum wheat, I think two seasons ago, or maybe this past spring. It's a lower rate, but we were able to apply that, again, over maybe a third of the acres rather than the whole thing. So not just the chem fallow piece, but some of those fringes where there is salinity seeping into the field. We could use that as an additional control measure. And we didn't have escapes within the rest of the field where we could have applied Authority. So we can apply, again, 20%, 30%, 40% of the chemical and maintain the same level of control. We did dabble in salt-tolerant forages. It's kind of a tough strategy to deploy because in the nature of putting these forages in the field, it does limit your herbicide options. So, and it's tough to get established. So year one didn't go great, but then year two things actually caught up pretty good. So was happy with how that went, but it's a technique I think you'd have to be prepared to really babysit, to sort of monitor closely if you wanted it to be effective. So here's a second year, different location, just with some zone-specific mowing, cutting. So we did establish that forage and did use some cutting techniques. Of course, there's areas of the field where just about nothing will grow. That's always going to be a concern for kochia, but and there is kochia in the forages, but it's a lot lower density than it had been previous to establishing that forage. So this is just a chart showing our 2019 to 2022, the different modes of action we used, how we did that herbicide layering, and the red dots are where we implemented certain site-specific controls. So again, tillage or chem fallow or mowing and cutting. These are different control mechanisms that we're adding to the system that just gives us an extra bit of control and allows us to kill off those plants that did survive, different modes of action through resistance. So what's next for this technology? I spoke a little bit about the real-time weed identification, and I think the opportunity here is for some of these soil-active herbicides. So we can spray chemicals where they need to be hit without having to see where the weeds are. So sort of an in-crop herbicide or sort of a pre-seed before the weeds are emerged, we can use this mapping to sort of get that targeted site-specific approach, reduce chemicals applied. A dual tank sprayer would be a really nice opportunity to sort of layer in, a different mode of action where it's needed. Instead of doing it across 160 acres, perhaps 40, 50 acres is really all that needs it. And I think the big thing, the big win would be drone spraying. And this technology, it's on the cusp. There's some regulatory hurdles, but within a year or two, I think there's going to be quite a bit of this happening. So this is sort of the background, laying the framework for where do we apply it, how do we know where to apply it, and when the drones are ready to go, we're going to be ready to take use of them. So with that, I just want to recognize, so CAP funded this project. FMC and AGM Seeds were big partners providing imagery and chemical, and some of the farm partners we work with. So Stamp Seeds we worked with, Laverne Gill and Croyman and Sons kind of worked with us to implement some of these strategies, let us walk through the fields, count weeds, all those kind of things. So it's very much appreciated having farmers, having growers sort of on the ground with us and then helping us to kind of do this kind of research. So with that, I think I've got time for a couple of questions.
Okay, questions for Lewis? Back here.
There we go. Hi, Lewis. Ken Greer from Western Ag in Saskatoon. Question about your Kochia outline. There's clearly some sort of is it an old road, or what's that? The bottom of that field had like a straight line of salinity and stuff going on. Is that related to where the irrigation went in, or why was, because it's related quite closely to your Kochia?
Yeah. So, oftentimes the salinity can be related. So we had one field where there's a canal quite like right next door to it. So there's probably some canal seep over years and years and years that would lead to it. So that would probably be what you're referring to. Yeah.
Okay, we had a Slido question. Is there a better time of day to use the imagery drones? What time of day? The challenges for shadows, leaf angles, etc. What's the best time of day to do it?
Yeah. So what's nice about our approach is we're looking for green on brown. So we're a little less subject to some of the minutia of getting perfect imagery because we're differentiating two very different things in the field. I think if you're getting imagery, you want a cloudless day. You want, this azimuth sun angle, so as close to vertical as possible. But I think with this approach, it's a lot more forgiving because, again, we're not looking to differentiate very similar things. We've got quite separate things. So I think there's a lot more space to be flexible and still have good data to build maps off of.
Yeah. What about wind?
Yeah, wind, same thing. If you were kind of trying to get an NDVI map from your field and evaluate, where the crop's growing well and not, wind is going to be an issue because all those angles are going to change all the time and your reflectance is going to change quite a bit. But when you get to, again, we're detecting green on brown. So whether it's moving or not, it's still going to be reflecting high in that green part of the spectrum and low in the rest. So wind probably wouldn't be a big deal for this application.
Right. Maybe just keeping the drone in the air.
From an imagery standpoint, wind probably isn't an issue, but yeah, you certainly wouldn't want it out there in 100-kilometer gusts.
For sure. Anyone else? Go ahead.
It all makes sense of why where you're seeing the issue. So is this potentially ready for adoption? Can farmers take this at this point and implement it on their farm, or what would be a barrier for adoption at this point that maybe stop it? If it's an efficient process, then...
So the question is this technology ready for adoption? What might some of the barriers to adoption be? And I'd say, you could go out and do this on your farm this next season. It would take a bit of work to kind of put together, to turn that imagery into sort of that green recognition, but there's a lot of stuff out there that could do that. So I don't know that there's maybe an app or something that could do that for you, but it's just a matter, it's easy to separate the green from red. So if you have a drone image that has NDVI, you highlight that green, you turn that into a prescription with your, software and you can apply it. So not that tough to do. It just sort of takes the time. I'd be interested to look at satellite imagery and how effective we could do with that. The resolution isn't as good, but again, depending on your use case, you may not need a resolution any finer than the width of your sprayer. So I think it just takes a little bit of work to sort of build that into your workflow. But people could use this technology tomorrow. Well, maybe not tomorrow, but in May.
All right, what's the best time of day to spray kochia?
I think with most weeds, you want to get them when they're metabolizing. So kind of in the heat of the day, before the heat of the day is probably the best time. But I don't know for sure. Hit them early. Hit them early when they're small. You're probably better off trying to hit them when they're young. So 2 weeks before today is probably the best time to get kochia.
Right? Is drone spraying combining weed mapping and spraying in the same pass?
So drone spraying, so you could integrate these technologies, like the drone could have the capacity to gather imagery as it's out there. I don't know that the drones out there have that. You usually pre-plan a map for them to do, so it's sort of a two-step process, because I think it's a little complicated to be gathering that reflectance and spraying at the same time. So in most cases, the drone would kind of have a pre-planned map. So whether that's doing a full quarter section or you've got a map that you think, hey, this is the area that we want to target things. So I don't know if I fully understood the question, but I hope that answers it.
There's one last question on here. Would satellite imagery work for mapping?
Yeah, which I think it would. It's just a matter of the resolution. But the advantage with satellite imagery is you've got like a 3-day turnover, so you're getting it quite quick. So you're not as subject to waiting for the crop to dry down, the color differentiation to be quite exactly right. So as long as you've got open cloud or no cloud cover, you sort of get, you can kind of go through the timeline and say, oh yeah, this one shows it really good. The only limitation would be the resolution. So if you have a sprayer that's sectional control or like nozzle control, you might be limited as to how precise you're going to be. But the other piece is we're not sure how precise we can be with the technology either. So when I look at a 10 by 10 meter square in the field, what's the threshold at which I'm going to decide to spray? How many weeds need to be in that square for me to spray? Is one weed enough to sort of spray that, or 7 weeds, or so I think there's probably some work there as far as at what point do we decide to actually take action, and at what point do we just trust the crop to be robust enough in this area to outcompete 2 or 3 weeds next year.
You guys had great kochia questions. Good job. Thanks, Lewis. And because you all did such a good job, I'm going to